Hello friends, in the previous lecture we were saying that what do you mean by consistent and inconsistent system. So today we are going to start new topic, that is a matrix notation of new topic is that new point is matrix notation to represent linear system. Okay, this is your today's new point to linear system. Okay, what is your new point? That is your matrix notation to represent a linear system. That means if we are given a system of linear equation, we have to represent that system of linear equation into your matrix form. Okay, so let us start this way. Consider a system of m linear equations. Consider a system of m linear equations in n unknowns. What do you mean by unknowns? That is your variables. Okay, if we have to consider system of m linear equation in n unknowns, that is variables, is your first equation become a11 x1 plus a12 x2 plus up to dot a1n xn equal to b1. Second equation become a21 x1 plus a22 x2 plus up to dot a2n xn equal to b2. Similarly, in this way, this is your first row, this is second equation. How many equations we have to fill? This is m equation. So your first element become am1 x1 plus am2 x2 plus up to dot amn xn, and your last b1 b2. How many rows? That is how many equations? That is m equation. Therefore last is bm. Okay, this is your system of 1 2 3 up to m equations in how many unknowns? That is n variables. This is x1 x2 up to dot xn. These are variables. Okay, so this is your system of m linear equation in n unknowns. Now this system can be written in, so therefore this system can be written, or this system can be written in single matrix equation. This system can be written in single matrix equation, that is your ax, capital Ax equal to b. We can write this system in single matrix equation. What is your single matrix equation? That is Ax equal to b. Okay, where capital A is, what is your capital A? This is your capital A. Okay, so what is your first row? That is first row become a11 a12 up to dot a1n. Okay, what is your second row? That is coefficient of x1, that is a21 a22 up to dot a2n. Right, this is your second row. What is your last m row coefficients? That is your am1 am2 up to dot amn. Okay, this is your matrix. So how many rows? 1 2 3 up to m. So what is the order of matrix? That is m rows and n columns. Okay, this is your matrix A. Okay, x. Next your x become, this is your x become your column matrix of unknowns. X become, that is your x1 x2. How many variables? How many unknowns? That is n unknowns. That is x1, x2 up to xn. What is the order of that column matrix? How many rows? That is n rows. And how many column? One column. And your capital B. Your capital B is your again column matrix of constants. This is become your B1, B2 up to dot dot Bm. Okay. So how many rows? That is m rows. And how many columns? One column. Okay. So here A is called as, where matrix A is called as coefficient matrix of system. Here capital X is called as column matrix of unknowns, and capital B is called as column matrix of constant. Okay. So write down. Due to space problem, I am using this one, where capital A is said to be, coefficients matrix, where capital A is said to be coefficient matrix. Your capital X is column matrix. Capital X is column matrix of unknowns. Column matrix of unknowns. And the name is variables. Okay. And your capital B is column matrix. Capital B is column matrix of constant. Column matrix of constants. Okay. Okay. Now, if you are to enter this your matrix, that is your, this is matrix. If you are to enter matrix A dot B, this matrix is called as augmented matrix for the system. What is your augmented matrix for the system? Consider the first matrix your A, that is A11, A12 up to dot dot A1n. Second row become A2, A21, A22 up to dot dot A2n. This is for your augmented matrix of constants B. This is your last row become AM1, AM2 up to dot dot AMN, and your last column matrix of constant B become B1, B2, Bn. So this is your B1, this is your B2 up to dot dot, this is your Bm. Okay, bracket complete. Okay, where capital A comma B is, what is this matrix? This is your augmented matrix. Augmented matrix of linear system. Okay, this is your augmented matrix of linear system. Okay, so how to write down this augmented matrix? We have to write the column matrix B to the right side of matrix A. Right? What is your augmented matrix B? This is your column matrix of constant. We have to write down this column matrix to the right side of coefficient matrix of capital A. Okay, this is your augmented matrix. Okay, now we have to solve this system of linear equation by using the elevated row operation. So our next point. So your next point is method of solving linear system. Okay. So we want to solve this method. So next point is method of solving linear system. What is your next point? Method of solving linear system. Right? So how to solve this linear system? So to solve the linear system by using the basic elementary row operation, and there are three elementary row operation. already we have studied in the previous lecture. So how to solve this linear system? So there are three-dimensional row operation. Before that, so write down to solve linear system. To solve linear system by using three basic elementary row operation. By using three basic elementary row operations. Okay, there are three elementary row operations. Similarly, there are again three elementary column operations. Okay, so first one, what is your first row operation? Interchange. First row operation become interchange any two rows. Interchange any two rows. That is, we can written as that is Rij. What is your first row operation? We have to interchange any two rows. That is, we can interchange Rij is, we can interchange row I and in row J. We can interchange row I and J also. Okay, this is your first row operation. Your second row operation become multiply all entries. Multiply all entries of any row. Multiply all entries of any row by a non-zero constant. By a non-zero constant. Okay, that is KRI. Okay, what is the second row operation? We have to multiply all entries of any row by a non-zero constant, where K is your constant. That is your row operation become, we have to multiply row I by non-zero constant K. So this row operation become K into Ri. This operation, it is called as this operation, that this row operation is KRI. It is called as scaling operation. Okay, it is called as scaling operation. Okay, what do you mean by scaling? We have to multiply by the scalar, right? Where K is scalar, constant is scalar. To multiply the scalar to any rows, and we have to multiply the scalar to all entries of any row. This operation is called as scaling operation. Okay, so write down last third elementary row operation. Your third elementary row operation become replace the row by sum of and replace the row by the sum of itself and multiple of another row. Okay, what is your third row operation? Replace the row by sum of itself. We have to take the sum of itself and multiple of any other row. Okay, multiple of any other row. That is, we can replace any row by the sum of itself row and multiple of any other row. That is Ri plus K into Rj. What is your row operation? That we can replace any row by its Ri, this is your itself row, plus scalar into other row, that is Rj row. We can just replace row by Ri plus Krj. Okay, and its row operation, it is also called as replacement operation. Okay, so it is called as I am right here due to space problem. Due to blackboard space problem, I am right here upward. So what is this one? Replace any row by itself by multiple of any other row, that is Ri plus Ki. It is called as replacement. It is called as replacement operation. Okay, it is called as replacement operation. Okay, so there are three elementary two operations to solve any system of linear equations. Okay, so let us write down demand. If write down demand. So write down demand, that is the solution of that each solution of new system, each solution of new system is also solution of original system. Is also solution of original system. Okay, what is your remark? If we have your system of linear equation, that is Ax equal to b, right? That is your Ax equal to b. This is your original system. What is your remark? Each solution of new system. Okay, so if we get this is your argument matrix. Okay, this is your argument matrix, and this is your original system. And if we get new system, that is we have to consider this is your Ax equal to 0. That is your right hand side is 0. If right hand side of the system is 0, then this system is said to be homogeneous system. We have to study after the lecture. If the right hand side of the system, that is b is 0, then this system is said to be homogeneous system. And if the right hand side b is non-zero, then this system is said to be non-homogeneous system. So what do you want? Each solution of new system. Okay, if we have given the non-homogeneous system and we get found that non-homogeneous system, we can write the homogeneous system. So this is your new system. So what do you remember? Each solution of new system. Okay, each solution of, we get the some solution of the new system. Each solution is also solution of original system. So we have to take the example on that remark and your system of linear equation. So what do you remember? Each solution of new system is also solution of original system. Right? That means if we get the solution of the non-homogeneous, if we get the solution of homogeneous system, then this is also solution of non-homogeneous system. Right? That is your previous solution also. So let us take the example on the system of linear equation. So write down question 1. Solve the following linear system. Solve the following linear system. So write down your system. x1 minus 2x2 plus x3 equal to 0. What is your first equation? x1 minus 2h2 plus x3 equal to 0. Second equation become 2h2 minus 8x3 equal to 8. Your last equation become 5x1 minus 5x3 equal to 10. Okay, this is your system of linear equation. We have given three equations, 1, 2, 3, three equations, and how many of those? x1, x2, x3. So we have given system of linear equation in 3 equations and in 3 unknowns, that is in 3 variables. We have to solve this system. Okay. So we have to discuss here how to solve the system of linear equation. Okay. By using the limit row transformation. So let us write down the solution. Solution. Consider argumented matrix. Consider argumented matrix for system. Consider argumented matrix for system is. So what is your argumented matrix? This is your argumented matrix AB. Okay. We have to consider the argumented matrix AB for the given system. So what is your argumented matrix? Argumented matrix contains to the column matrix to the right side of matrix A. What is your A? A is your coefficient of matrix. Okay. What is your coefficient matrix? That is coefficient of x1, x2, x3. Right. So this is your argumented matrix. So what is your first row? First row contains the coefficient of x1, x2, x3. So your first row become 1, coefficient of x1 become 1, coefficient of x2 become -2, and coefficient of x3 again 1, right? And in the right side, so your column matrix B1 contains only first constant 0, right? This is your constant 0, right? So your second row become coefficient of x1 become 0, right? Coefficient of x2 become 2, right? Coefficient of x3 become -8, and coefficient of last constant become 8 here. Similarly, your last row, coefficient of x1 become 5, coefficient of x2 is 0, coefficient of x3 is -5, last constant is 10. Okay. This is your argumented matrix AB, right? So we have to solve this argumented matrix AB. So solve the linear system. That means we have to find the value of x1, x2, x3. Okay. For that, to find the value of x1, x2, x3, we have to solve this argumented matrix by using the 3-element row operation. That means we have to convert this coefficient matrix A, right? Or I am saying that we have to convert this matrix A, that is coefficient matrix, to the upper triangular matrix, and we have to make the all diagonal entry become 1. So what is your goal? We have to make all diagonal entry become 1, and below that all diagonal entries of below part, we have to make that all entry become 0. Okay. So we have to make this by using elementary row operation. So first step, we have to make the first element become 1. So already this element is 1. Okay. So next step, we have to make that 2 entry. So first and third rows of first element become 0. We have to make that 2 element is 0. That 2 element. So this element already 0. We have to make this element is 0. How to make the element is 0? We have to take the row operation. What is your row operation? What is the element in that row? So this element in your row 3. Okay. This R3 minus 5R1. So we have to do this row operation in R3. Okay. What is your row operation? We have to make this element is 0. This element is present in row R3. So R3 minus. We have to multiply first row by that -5. So 5 minus 5 become 0. Okay. So this is your again your matrix become right. So your first and second row as it is, that is 1 minus 2 again 1. This is 0. What is the second number? 0, 2, minus 8 and 8. Right. What is the last third row? Again 5 minus 5, 0. Right. 5 minus 5, 0. What is the next one? R3 is 0 minus 5 into minus 2. Minus become plus 5 into 2, that is 10. What is that element? That is 10. Next element is this is your minus 5. Minus 5 again minus 5 into 1. Right. Minus 5 into 1, that is minus 5, and then minus 5 into minus 5 become minus 10. What is this value? This value become minus 10. What is the last one? R3 is 10. 10 minus 5 into 0, that is 0. 10 minus 0 is 0. What is that value? This value is 10. Okay. So next step, we have to make that diagonal element is 1. How to make this 1? So divide R2 by 2. Okay. So next operation is R2 by 2. Therefore, your equivalence matrix become, right? Your first row as it is, that is 1 minus 2 1 0. What is your second row? We have to divide second row by 2. That means we have to divide each element by 2. So 0 upon 2 is 0, 2 upon 2 is 1, minus 8 upon 2, that is your minus 4. Okay, and 8 upon 2 becomes plus 4. Right? This is your partition for your right hand side. Your third row as it is, that is 0, 10, minus 10, and last is plus 10. Okay. So what is your next row operation? We have to, next step is we have to make the third element of third row of second element is 0. That is, we have to make that the diagonal element, that second element to 2 position. We have to make the back below that A32 element. That you have to make this 10 is 0. How to make the element is 0? By using that second row. So what is your row operation? This element present in row R3 minus, we have to multiply by this element is 10. So 10 minus 10 becomes 0. So what is your row operation? R3 minus, multiply by this element by minus 10 into R2, and this is present in your R3. Okay. So your matrix becomes, your first row as is, that is 1 minus 2 1, this 0 as it is. And your second row become as it is, that is 0 1 minus 4 and this plus 4, right? What is your last third row? Again 0 minus 0 0. Okay. Next is again R3 is 10. 10 minus 10 again 0, right? Again next is R3 element is, what is your R3 value? Minus 10, right? Minus 10. Again this minus 10 into minus 4. So minus minus plus. Minus 10 into 4, 40 plus 40. And minus 10 plus 40, that is your plus 30, right? Again, what is this last value? Here value is 10. So R3 is 10 minus 10 into 4. Minus 10 into 4, that is minus 40. Okay? And 10 minus 40, this value become minus 30. Okay? This is your argument values. What is your next step? We have to make this element is 1. That is your A33 element is 1. How to make this element is 1? So divide third row by 30. So your row operation become R3 by 30. Okay. So your equivalence matrix become. So this is your first row as it is 1 minus 2 1. This is 0. Your second row as it is 0 1 minus 4 and plus 4. What is the last row? 0 upon 30 0. 0 upon 30 0. 30 upon 31 minus 30 upon 1. This is your minus 1. So your goal is complete. That is, what is your goal? So we have to make the all diagonal 1. So this all diagonal become 1. And below that diagonal all element we have to make 0. So this all three element is 0. So our goal is complete. So what is the next step? We have to equate that the both sides and multiply the first row by x1 x2 x3 and equating to the right side, then we get, so we get after that equating, so your first equation become multiply by first element by x1, second element by x2 and third element by x3, then we get x1 minus 2x2 plus x3 equal to 0, right? Second equation become 0 into x1 is 0, 1 into x2, so that is your x2, again minus 4 into x3 equal to plus 4. This is your second equation. Call as equation 1. Call as equation 2. What is the last third equation? 0 into x1 is 0. 0 into x2 is 0. And 1 into x3 is x3. So we get value of x3. What is value of x3? Value of x3 become minus 1. Value of x3 is minus 1. Call equation 3. So we get value of x3 become minus 1. Put equation 3 in equation 2, then we get value of x2, right? So write down. So we have to write down us the value of x2 in equation second. Okay. So put equation 3 in equation 2. Then we get, right? So what is your equation 2? That is your x2 minus 4 into, what is the value of x3? x2 minus 4 into x3, value of x3 become minus 1. This minus 1 equal to 4, right? So minus 4 minus 1 is plus, become plus 4. This plus 4 shift to the right side, then this minus 4 becomes, okay? So this is your x2 plus 4 equal to 4. Next step is x2 equal to 4 minus 4. So value of x2 become 0, okay? Value of x2 become 0, right? Call equation number 4, okay? Now put value of x2 is 0 and value of x1 is minus 1 in equation 1, okay? So next step, put values of x2 and x3, right? Put values of x2 and x3 in equation first, then we get, what is your equation 1? x1 minus 2x2 plus x3. What is equation 1? x1 minus 2x2 plus x3 equal to 0. So if x1 minus, what is the value of x2? 0. So 2 into 0 plus x3 become minus 1 equal to 0, right? So 2 into 0 is 0. So this value is minus 1. Shift minus 1 to the right side, then plus 1. So value of x1 become, plus 1. So therefore we get value of x1, x2, x3. So what is your solution? Therefore your solution is, your solution become, so we get x1 equal to 1, x2 equal to 0 and x3 equal to minus 1, right? This is your required solution, okay? So this is your example of system linear equation. So we have to discuss how to solve the system linear equation by using the limited row transformation. So I hope all parts we have to understood. So remaining part we have to study in next lecture. Thank you.